Welcome to talk. We got Nate from the internet here. We got Stefan from CNC Kitchen. We have Dora from StrelkoMania. We have Tom Stanton from Tom Stanton. And there's one more. Is someone missing? Does anyone see? I don't know. I thought we had one more person on this talk, but I don't know where they are. Anyone? Oh, Ivan. Yeah, has anyone seen Ivan?
Ivan!
Oh, hey, Ivan.
Oh!
Wow, just rocking up.
Sorry, it was crazy on the interstate.
Sorry. Is that street legal, Ivan?
No, it's not. It's not. Absolutely
Is
not.
it PLA? Like typical?
It's
use?
PLA. If it stays for too long in here, it will take the shape of the floor. So, yeah.
So we're assembled here as a group of people who use 3D printing to make a range of different things. So as you can see, Ivan, tell us a little bit more about your motorcycle.
It's a 3D printed motorbike that fits in a suitcase. It runs with tool batteries that you can put in your drill or whatever you use. And it has lights. I don't know if you can see the lights. Yeah. And it also makes noise, has a storage space under the seat, and yeah, super practical and also super fun.
So this motorcycle is made with any like special material?
No, this version is made with fancy materials because it had to be super light to bring it here in a suitcase. It was checked in on a plane, but the one that I have at home is printed completely and absolutely in PLA, even the wheel axles and everything. This is TPU, flexible TPU, and the tires are just regular rubber tires that I bought on Amazon, but the rest is all basically PLA.
Speaking of TPU, Dora, I heard that you made something kind of interesting with TPU recently.
Yes, and I'm going to need to ask one of you to hold my microphone because I need 2 hands. Okay, you got to stand up. So I don't know about you guys, but I often forget my belt, which results in using a zip tie to hold 2 loops together. And that's why I 3D printed a giant zip tie belt out of TPU. So when you think about a zip tie, the front of the zip tie comes straight out. So the mechanism, you have to turn it 90 degrees so it fits nicely into your loop. So I added a little back kind of buckle that moves the ratchet mechanism backwards so that you can hopefully easily pull your belt right off.
Can we get a microphone on the zipping sound?
Okay, let's see if this will work.
Drum roll, please. Nice.
Thank you. And don't worry, my pants will not fall off. They're the right size this time.
So using 3D printing to bring ideas to life is definitely one of the best uses of the tool. Nate, I've seen something that you've built where you've really used 3D printing to bring something massive to life. Can you just tell us a bit about what it's like to employ 3D printers to build something full scale?
Some people may know, I, over the past about year, built a Lego-inspired castle that was big enough that you could walk around in it. It was about a 20-to-1 scale to a regular Lego set. As far as I know, it's the largest FDM 3D print anyone has ever done. If there's something bigger, I'd love to see it. So I had to engineer pieces that could be printed on a regular hobby printer that could then be assembled together to stack and build the way Lego sets do to build that castle. And it was genuinely like an experience of using a printer to take something that had only existed in imagination. I think Lego is fantastic for being this imagination tool and turning it into a real life, something you can experience by being inside it, not just playing with the little figures on it. And I don't know of another way that such a thing could have been done at a hobby level.
100%. That is, it's insane. And we're also lucky to have an audience, like people like you, who allow us to make things that otherwise maybe don't have a big reason to exist. And so thank you all for allowing us to do that. But on the note of something really big, on the complete opposite end of the spectrum, Tom has been using 3D printing to make things like small and ultra lightweight.
Yeah, so I like to think of 3D printing just as a tool in general. I CNC things as well. As 3D printing could just, well, if you're good at CAD and you have a 3D printer, you could make almost anything. It's amazing. We were talking earlier about, I've been watching all the Mythbusters episodes again recently, and watching them make the projects without 3D printers is really interesting. And I sometimes wonder, if they did have 3D printers back then, maybe it would take a bit of the creativity away from it, but it would have changed the projects completely. Like there was the one with the golf ball car with all the holes and everything in it, and they covered it in clay and had to cut the holes out of it. If you just 3D scanned it and printed a whole bodywork, I don't know whether it would have been quicker, but it may have been easier.
It definitely would have been lighter.
Yeah, definitely, yeah.
On the note of like 3D printers and how far they've come, Stefan, you've been in the game for a very long time, and you've seen a lot of printers come and go. How do you feel about where 3D printing is at now and the level of capabilities of the technology?
I think one of the big things happening over the last few years was accessibility. If I see my wife these days just using 3D printing to print stuff that she needs and she wants, it's an amazing thing for me. I did a 3D printing class in a school where I can see young students having ideas, going into Tinkercad, sketching them up, and after a press of the button, half a day later, they have their things ready. And this gives an amazing tool into the hands of makers and so many people that we didn't have in the past, and that inspires creativity. That is creating the engineers of the future, and this is one of the nicest things I think that technology has evolved to. Of course, technology-wise, the printers got faster, materials got better, but not needing to be a 3D printing nerd anymore just made it so much more accessible and brings so much more people into the hobby and into engineering, and I think that is something very important for us and for the future.
Well said. Totally agree with everything. On the note of speed, because for me, the printing speed has really changed the way that I operate and work. Ivan, you've been printing some pretty large-scale, very complicated mechanical assemblies. How has printing speed changed your process?
Well, printing speed, like iteration is king when developing new stuff. So not having to wait like 6 days for a new part is great. But also now the technology is evolved enough that I've been able to make my own, for example, my own extruder for my large format 3D printer, where I can print up to 200 cubic millimeters per second. So you can see the spool and spooling at this speed on the printer. You can see the filament going in at full speed, and that means that you can have like a 4 kilo part in 1 day. But allows you to think further and thinking, okay, if I have 2 weeks to do this, now I can make it 3, 5, 10 times bigger than 3 years ago, which is amazing.
If anyone hasn't seen that 3D printer that Ivan made, you have to watch that video. It's insane. But it's cool that we're able to not only use these tools, but also use these tools to make new tools. And it's something that we can always be proud of, is like coming up with an idea and figuring out how to bring it to life. So Dora, what is one of the things that you've been able to bring to life with 3D printing that you maybe wouldn't have been able to make in the past?
This is a very loaded question. Okay, so we all know and love our headphones, right? But they're kind of super boring and generic. For example, a lot of us probably have the same color and shape over ear headphone. I'm kind of tired of just everyone looking the same. So I was looking to build some headphones in the shape of a star and add a very unique stripe pattern to them. And with 3D printing, it made it really easy not only to hollow out the shape, but use an infill that would make it sound a lot better as well. The phone cushions are also star-shaped, and if you think about a long time ago how I would make it, I can only imagine what would I do? Sand cast it, maybe use thermoplastic that I'd have to melt and mold by hand. It really made like unique shapes much more possible, lightweight, as well as considering that acoustic element. And I'd like to throw in the fact that they were heavily inspired by the Hedemame fully 3D printable headphones. So yeah, definitely something I'm the most proud of because it's the most unique. And with 3D printing, you can really stand out and be something different in the crowd.
It's definitely fun to be able to make things for yourself, make them because you want them to exist. And there's some new technologies that are coming up. I don't know if you've heard of them. We're gonna call it AI. But Stefan, what have you recently built that isn't necessarily 3D printed, but is related to 3D printing?
So I'm a mechanical engineer, so I use normal CAD software for more than 20 years now. And one of the things I have been struggling with if I make functional parts was that all of the surfaces of my part, they were pretty smooth. And if you want to like texture parts, you either gotta learn Blender or you need to play around with fuzzy skin. That's pretty limited. So at some point I thought, wouldn't it be cool to have a really easy to use tool to add different textures on 3D prints for functionality and also that they just simply look better. With the agentic coding tools that we have at hand today, I tried to make exactly a tool for that, which is out now. It's called Bump Mesh, which everyone can use free, it's open source, and I've been working many weeks on really to optimize the workflow, that you can load in your STL, that you can select the surface, that you can select the texture that you want. Then the parts get textured. Of course, the mesh size increases tremendously, so I had to implement simplification tools in it again. And it's amazing what I was able to achieve, and also then give back to the community, because I solved the problem that I had. Agentic coding gave me the possibility to make that tool, and making it open source was for me kind of a way to give it back to my community and also have that community help me to improve it even further. And I think that is not only the spirit of this tool, but the spirit of 3D printing as we know it today in general, because lots of the things that we do these days are based on RepRap being open source, on freely sharing our ideas and the things that we made, and I think that fits very well in that niche.
The ability to bring an idea to life, and it's an idea that is now building on top of something that we were already using to bring to life. But within the confines of a slicer, Tom was just telling me about some very interesting stuff he's done to optimize some of his designs with infills and stuff. Tom, can you tell us a bit more about that?
Yeah, it was a little while ago. I made a 3D printed wing, which a lot of people have done, but I was trying to figure out a way, because basically with lightweight PLA, which foams as you print it, it is awful with stringing, because when you retract it, it still oozes out a bit. So I tried to design a wing that could be 3D printed in vase mode, but still had internal ribs. It was a bit of a complicated CAD model to try and trick the slicer into just drawing a constant line, and it would have to sort of go in and do the rib, and then it was quite complicated to explain about the video. But I love hearing other people's ideas of how they like hack the slicers to do various things. And well, I'm sure Stefan knows more about.
I did when I did last year. I printed my kayak. I wanted to print it in less than 24 hours, and I didn't want to have any retraction. I was printing with the hot end at 280 degrees with PLA. So what I did was I took a lot of time to design the entire kayak to be able to print in vase mode, even the hole where you sit in it, and the reinforces where you are sitting, so the walls are wider. But also thinking that was going to be printed in a belt printer that prints at 45-degree angle, which like breaks your mind trying to think about how the slicer is like slicing in 45 degrees, and you have to keep a continuous line back and forth, doing double and fourth 4-layer walls in a single go, and seeing like the machine going, and the extruder not stopping, and the spool unspooling like took 21 hours more or less to print a 3.5 meter long kayak that I could fit in. So yeah, hacking the slicer to think you're in vase mode is really useful.
One thing at first sounds unintuitive, but the thing that I very regularly do is putting holes in my print to make them stronger, because if you have like highly stressed areas and you're just adding like tiny holes and bores, the slicer will add additional perimeters around that regions, counterintuitively making the part stronger in that area. And I think this is one of the really neat slicing tricks that when people learn it, they will constantly use it.
I'd like to jump in on that too. So I was exploring a lot of 3D printed origami for both fashion, and then just for fun, I made like a 3D printed origami frog that could still jump. And when it comes to the slicer, something I quite use often is print pauses to combine different materials together. So when you think of origami, it has your living hinges, which are flexible, and then your rigid elements, which are those panel pieces. You can print really thin, rigid pieces in your PLA or maybe your PETG, and then pause it within in your flexible print to get that rigid element. You can also do it with special materials that foam, like VarioShore TPU, by hacking the slicer to change print temperatures mid-print. So that's been a really big game changer, is mixing multi-materials if you have a single extruder hot end with pauses to get very unique geometry like an origami.
It's pretty spectacular what you can do with multi-material printing, but sometimes it's not even about doing it all in the same part. Like I know Nate here has this Vortex blaster, which tell us a bit more about how you've used different materials on this blaster.
My goal with this is, as a project that I started many years ago, I decided I wanted it to be as 3D printed as possible. This whole thing is put together using exclusively 3D printed parts and 6 rubber bands. So I don't have any external hardware, don't have any other parts that can't be printed. I do have multi-material though, so almost all of it is PLA, which I think is the most standard 3D printing material. And then I have one piece that's flexible, made out of TPU, which is the most common flexible material right now for printing. Combining those types of things together, you can get rigid, you can get flexible, and just by using them in the right places, it was what enabled me to come up with a project that people can just print themselves. And when I first started coming up with this idea, I was like, oh, I'm gonna have to sell like a hardware kit of like all just the right springs and screws and pieces and plastic membrane, and I'm so glad I was able to move away from that because it makes the whole project so much more accessible.
I have a question for you, Nate, because I suffer from that too. This motorbike has 1 million screws, and there is no way that I can make it without them. But how much harder is to think about making something like that without hardware than with hardware?
Definitely, I think you should answer this one actually, because you've run into it probably more than I have. This is kind of like my first project of this type, and I definitely had to redesign all of it to clip and friction fit together. But yeah, you've probably had to deal with it more than me.
Definitely over the years, trying to make mechanical assemblies that are fully 3D printed. But in the end, I've kind of come up with like a system of 3D printable hardware. You can't really escape the hardware all the time, although you have some pretty nice friction fits and detents.
In this one, it worked, but I am not convinced at all that I could avoid it forever. It's just, this is something I could. This is not as complicated as a lot of stuff.
I find sometimes the simpler looking designs take the longest to design. Because especially with 3D printing, I always try and fit as much of, what I can into one print.
Yeah.
Instead of just doing multiple prints and then gluing or drilling or melting, Yeah, so the simpler looking design always takes the longest, I find.
Definitely, it's a bit of a mind warp trying to take something that you're like, could be very simple, like putting an axle through a wheel, and now deciding that you have to design this for additive manufacturing. It's a term that Dora told me about today, DFAM. Does anyone here have any like really interesting DFAM designs that like they're very proud of?
I have a few of the features on the bike that are meant to be done so it doesn't break because everything is 3D printed, and sometimes you cannot choose the orientation of the parts. So I have, for example, in the bottom, you can see here. Like in the bottom, you can see here is a bar. It's printed in a different orientation. So you can just add a different part that adds to the structure so it doesn't break. Same on the seat. But you have to put your butt in here, so it's good if it doesn't break. So it has a beam in here, and you have to think about that in terms of it being 3D printed. So you cannot think, I will add a metal beam in here, or like if this handle is gonna hold up. You have to think always in terms of how people are going to make this with a 3D printer, and if it breaks, will they be able to replace it, or will I be able to improve the design further if I see that something breaks often? And I can make something that is stronger, or add something that makes it more reliable, or fixes the issue.
100%. Parts printed vertically, it could break on the layer lines. Is that the reason why you added that bar in the bottom there?
Yeah, exactly. Like the bottom has to be printed flat on the bed like this, so the layers go like this. So that's not the optimal layer orientation to have this hanging in here as putting our feet in here and the weight. So the print that is in the bottom is printed like this and then inserted like this. So the vertical layers add a lot of rigidity. And also, if you don't want to print the entire bike in fancy material, but you want to do only that part maybe in polycarbonate or ASA, you can do just that one part that will solve most of the weaknesses of the bottom of the bike.
Yeah, it's interesting with the how the printing affects the designs. I know a guy who's been an aerospace engineer for 20 or so years, and he's been working mostly with machining parts. And he recently bought an FDM printer, and he's had to completely relearn how to design things, trying to avoid supports and, the structural way to print things. And
with machining, you try to remove as little material as possible because it takes a lot of effort. And with FDM 3D printing, you try to add at the least amount of material possible, so the design goes completely the opposite direction. So
Designing specifically for 3D printing, and I think a lot of us are afraid of designing using supports, but sometimes you can just be like, forget that. We're gonna just not put that constraint, and we can just print with supports. And Nate was just telling me about the part inside that's your trigger mechanism that uses supports specifically.
There are a few parts of this that, they are oriented in the right direction for strength, but they're difficult to print like that. And especially, there's this little tri-prong mechanism that grabs inside it. And I wanted it to be uniformly strong on all three prongs, but it also has to bend. It's what's called a compliant mechanism. It works by bending as a hinge, sort of. I had to design that to be sort of enshrouded by, it's got supports on all sides of it that aren't actually touching it. They're just there to make it so these spindly little bits don't wiggle back and forth too much in the machine as they're being printed. So it just holds everything right in place, and it's secured at the very bottom with just like a very thin bit. So it all prints looking like this weird block, and then you cut little flanges at the bottom, and then the true part emerges out from the middle as this sort of like, the diamond in the rough that was this block. And it's definitely an engineering challenge, but it makes it so much more functional. So that's a fun little puzzle you gotta design.
I like that. Very interesting concept to design in supports in CAD before you even get into the slicer to help you get like an optimal part. So I think at this point, we'd like to open it up to the crowd. If anyone has any questions for anyone here on the panel, we would love to hear them.
In the realm of multi-material printing, we're kind of seeing a revolution going from systems like the AMS, where you're changing the filament in the nozzle, to more tool changer-esque printers. In regards to these changes, how do all of you feel about moving towards either a nozzle changer, a full tool changer, or even just sticking with an AMS type system? How do you feel about these developments?
I think everyone needs to ask themselves what they really want to print. I think if you want to go into multi-material printing, if you want to make these engineering parts, nozzle changers or tool changers make way more sense because you don't have that contamination of other polymers in there. If you are just very seldomly print multicolor parts, an AMS system is totally fine. It removes a ton of complexity. I think for many people, just what we have is sufficient, and there are these use cases, lots of multi-color printing and multi-material printing where these new systems make a ton of sense. But looking at like full color, full spectrum G-code and things like that, these systems now also open us way more possibilities that we have before, and I think we are just at the start to taking really advantage of that, and I'm really looking forward to what software can bring us to improve the systems that we already have, and I'm super excited about that.
I love the idea of the multi-tool. Like, I don't do a lot of decorative color swapping. For me, an AMS is functional, but not how I use 3D printing. Not that there's anything wrong with the people who do, that's fantastic. But to me, the idea of one nozzle per material type is perfect. So most of the time it's gonna be two. Like, I love using like PETG supports for a PLA part or vice versa because they pop apart so nicely. But then if you also wanted to like add in a TPU or something else, I love multi-nozzle for multi-material, and I'm super glad that more of those are coming out.
Bringing it back to kind of the mechanical engineering aspect, it's really interesting thinking about tool changers because we all look at tool changing to the same tool, but what if we add different nozzle diameters or something that's high flow versus a standard nozzle? You're starting to add basically multi-tools into that one printer. By staggering different sizes of beads, you can get very fine prints in a certain area of your wing, or maybe very larger, kind of you don't care about the surface finish or the geometry in another area. It can improve the structural integrity quite a bit. Or with high flow, low flow, you can switch between two different materials, and by having a different tool, you don't have to worry about oozing for something that's high temperature like a TPU versus a PLA like in my origami. It would save a lot of time. And the software That might take a while to catch up, though.
Just one last thing I want to add on that, though, is you can get a lot done with just cheapest printer on the market, single tool, and with creative design and engineering, you can mix materials together to achieve a lot of things. So you don't need the technology to take advantage of the breadth of what we have available. Let's go to the next question right here.
When do you guys expect metal 3D printing to become more affordable and consumer friendly?
It's taking too long, for sure. I want one. It's really a challenge, a technical challenge too. Because the temperatures are crazy, the materials are crazy expensive now, but like the sooner the better. I think all of us could make use of one of those cheaper metal 3D printers now, right?
I think the conventional systems that we use these days, mostly with powder, there is the big challenge of making those machines safe to use, because working with metal powders is something that you typically don't want to do, sometimes flammable and things like that. Companies need to come up with different solutions, but if you require things like this, there are solutions these days already on the market using metal-filled FDM filaments that you burn out and sinter in the end. It might not give you the results from a real powder bed laser printer, but could also solve your problem right now. But I also think it's quite a way to go there to make them really affordable. And I'm also asking myself, having experience with that system, if I want to give them in the hand of everyone, if it's powder based.
Yeah, and you can kind of think about manufacturing metal in a different way by using 3D printing as your tool. So while you might not have access to a powder bed or something that uses lasers, you could use the lost PLA method by 3D printing your model in PLA and then maybe casting it with a sand mold by using that to create it. It's really about, that typical saying of the world is your oyster. Well, 3D printing is your oyster, and the world is still the world. But now you have all this beautiful tool to just reinvent how you think about the building process in general. So, my friend, it's about how you define metal 3D printing.
We got a question over here.
First, thank you. This was wonderful. I have a question about, where we see the next advancements in 3D printing and really as it comes to hardware or software. We've seen a lot of advancements in faster printing, multi-material, tool changers, and I get the sense that we're leaving a lot on the table as far as kind of the slicers and software goes. We're starting to see things like implementations of non-planar, and I just want to get the panel's thoughts on kind of where we see that going next.
I'm super stoked for software. If anyone is asking me, should I invest in creating
The 3D printer of the future or the slicer of the future, I would say the lower hanging fruit, even though it's difficult, is slicing technology. We are still printing 2.5D. There are nonlinear methods, there are different slicing methods that can improve not only the looks, but also the strength of parts. So I'm really looking forward to, and as I said before, one of the really nice examples is that the full spectrum G-code, which showed how I can use the machines that we already have, just right now already do full color 3D printing with just 4 different materials.
I think obviously the end goal is, what we were saying about designing stuff to be 3D printed. It will be, you'll have a printer which you don't have to worry about any supports, any overhangs, anything like that. That's obviously difficult to do. And as you said, the 2.5D printers that we have now, they do 99% of the things that we can do. So when you get to more multi-axis, non-planar printing, I'm guessing that will be a little way off before that becomes full mainstream, just because most parts can be made on a regular machine.
Thank you guys so much for joining us here.
Thank you, everybody.
Thank you. And go make something.
Let's go and make something!
Thank you.